propagation in free space, the continuation of the characteristics impedance, we found the wave propagation in free space. Before that, I would like to share some few points that is related to the characteristics impedance. So you find the E and H from the previous term, like that is the EY by HZ, it should be equal to mu naught by mu by epsilon, that you are derived, that is the characteristics impedance. That is for the EY, that is the electric field in Y direction and magnetic field in Z direction. From that you founded the characteristics impedance. Likewise, in the all expression, that is the HZ by EY we obtained. Similarly, you can find HY by EZ also. That is the HY by EZ also we can found, that also it will come the same thing. Similarly, HY by EZ also, the HY by EZ also we can found the characteristics impedance. So as we found the core expression, from that we can found the relationship between the electric field and magnetic field, and finally you may obtain the total electric field and total magnetic field. If wave is traveled in the x direction, the total electric field becomes like that, the square root of EY square plus EZ square. Similarly, the wave is traveled in the x direction of the magnetic field, so the H should total magnetic field it becomes like that. The H should be equal to the square root of H square, Hy square plus Hz square it will come. So the ratio between the electric field and magnetic field, obviously from all these derivations, you can find the square root of mu naught by epsilon naught. That is the characteristics impedance we notated as eta. Okay. So if you are substitute the constant value, mu naught it have the constant value, epsilon naught also it have the constant value. Both if you are substituted, we can found the resultant value, that is the numerical value, that is the 125. Here we are consider the characteristics impedance, the unit we are written. So if you are simplified the 120 of, it may come 377 ohm, right? That is the characteristics impedance. So the continuation of this, the wave propagation in the free space. So here also we consider for the wave equation in free space, del square E, that is the mu into epsilon into dou square E by dou t square it will come. We consider for the expressions like that in terms of functions. So the here E it should be of x comma t. So the real part of E of x into j omega t. That is the we can written from the formula, right? So similarly we can substitute instead of E, we can substitute because the E electric field is in the x direction with respect to the time. So we can write like that. So instead of E, you can replace this all term. Here it is also is there. Here also is there. So you can replace it. So after the replacing, you can simplify it. Here the real part, this value will come. But here it is the dou square by dou t square measure. So you need to make the differentiation with respect to t. Here this t is there. So once you are t is there, j omega t. While you are making the differentiation, the omega t here minus omega square it will come. While you are making the 2 times differentiation, minus omega square, because here it is the j is there, right? So minus omega square, remaining e term, similarly remaining term it will come, right? So you obtained this expression, the constant as it is you can return. So now you can segregate all real part in the one direction. So commonly you can take the real part of, that is the electric field, that you can write del square into E into e power j omega t. Then that is the RHS side, it is there in the negative sign, while you are shifting from RHS side to LHS side. So here the positive sign it will come. See here it is, my negative sign is there. This negative can be eliminated while you are shifting from RHS side to LHS side, right? So mu into epsilon into omega square e power j omega t equal to 0. So here again the e power t is the constant, so that you can take it commonly. So that if you are take it commonly and you can shift in the RHS side, the 0 can multiply with this entire term. So what it will come? The e power j omega t also getting 0. So the remaining this expression alone we can write the del square e plus mu epsilon omega square into e equal to 0. That is the vector Helmholtz equation. That is the, they may ask you the vector. There is the vector Helmholtz equation. They may ask you like that. If they are asking you, you can write the wave equation. Then you can make the simplification and find the equation of the vector Helmholtz equation. So here the same equation we can write like that. The beta square into e. While you are simply I change this term in terms of beta. So the beta square is nothing but the beta was the phase shift constant. Okay, the alpha is attenuation constant, that also we derived in the upcoming equation, but here we are simplified this term. The beta it should be equal to mu epsilon into omega square, that is the phase shift constant. So you need to obtain the beta alone, so it make the beta square it is there, so we make the square root of mu into epsilon into omega. So if you are written that again the velocity, in terms of velocity, v it should be equal to what it is there. So mu divided by beta, so you see here it is mu is there, then if you are written the beta, what it will come? Mu divided by omega divided by beta, what it will come? That is the velocity. In terms of velocity you need to obtain, that is the omega divided by beta, where beta is the phase shift constant, it is the angular velocity, that is the wave velocity, that is the speed of the wave, right? So here E it should be equal to the same expression. You are written the phase shift constant as well as the velocity. So if you are simplified this expression again, you can write like this: C1 into e power minus j beta x. Similarly, C2 into e power j beta x minus, as well as the positive direction as well as the negative direction. The electric field has been traveled in the both the direction, positive and negative. That is the C1 and C2. The constant C1 and C2 you will find from the propagation, wave propagation itself. Okay, that is the actual wave propagation equation in the free space. Okay, thank you.